Welcome back. In today's video, we are going to dive into key value store databases, one of the most straightforward yet powerful data models in the NoSQL world. You will learn what they are, how they work, and why they are often the go-to choice for high-performance application. As always, we answer the question of what is a key value store? A key value store is exactly what it sounds like. Data is stored as a collection of key value pairs. Think of it as a giant dictionary or hash map. Each key is unique and directly reference its associated value. There is no complex schema like in relational databases, making key value stores incredibly flexible and easy to scale. Okay, let's try to understand how does it work. First, we want to talk about the data model. We have keys and values. The key is a unique identifier, often is a string, number, or combination of both. The value, which is a data or information you want to store. It can be text, JSON, XML, or any serialized format. And second, we want to talk about how the lookup process happens. The application sends a key to the database. Okay, the database finds the corresponding value. Sorry, that's the corresponding value. Okay, in constant or near constant time, O of one complexity in many implementations. Because of their simplicity, key value stores are extremely fast at both read and write operations. This makes them ideal for scenarios where speed and flexibility matter more than complex query. Okay, right now we need to talk about some popular key value stores. We have Redis, which is it's often used for caching, real-time analytics, and session management. We have the Amazon DynamoDB, which is a fully managed NoSQL service on AWS. We have Memcache, which is a high-performance distributed caching system. Each has its own features and trade-offs, but they all follow the core concept of storing data as key value pairs. Okay, what is the use cases of key value store? Like in your system design interview, in which use cases you will prefer to use a key value store as your primary database? First, caching and session management, like storing user session in high speed in memory store like Redis. Number two, user profile storage, like storing user data where you only the quick lookups. Number three, configuration management, like keeping configuration details that need a rapid access. Number four, in the real-time analytics, like counting page views, like or other metrics that updates constantly. Key value stores excel in situations where low latency is priority and the data access pattern primary involves straightforward lookups or updates. Okay, what are the pros of key value stores? First, simplicity. It's easy to understand and implement. Second, high performance. It's near instant read and write time, especially with in-memory databases. Number three, scalability. Easily to scale horizontally by sharding or partitioning data. Four, flexibility. Like no need to adhere to strict schema. Okay, what are the cons of key value stores? First one, we have limited query capabilities. Like you can perform complex joins or queries like relational databases. Number two, possible data inconsistency. Like sharding and replication can introduce eventual consistency challenges. Number three, data modeling. Like if your data needs complex relationships, a key value store may not be the best fit. While key value stores shine in speed and simplicity, they aren't a one-size-fits-all solution. For more complex query or strong consistency requirements, you may need a relational database or different type of NoSQL system. Okay, right now, are this is what are the best practices? First one, you need to design your keys carefully, like use clear naming convention and consider namespacing. Number two, keep values compact, like storing huge blobs can slow down retrieval. Consider splitting large data into smaller chunks. Number three, plan for sharding. If you expect rapid growth, think about how to distribute keys across multiple nodes to avoid hotspots. Number four, leverage expiration, like for caches or session data, set a time to live to automatically remove stale data. Number five, monitor and alerts. Track performance metrics like latency, hit rate, memory usage to cache issues early. Okay, now we come to the conclusion. So, and that's it for this video. The key value stores databases are a versatile option for application needing fast and straightforward data access. They might not replace relational databases in every scenario, but they are powerful tool to have in your backend arsenal. If you learn something new or you're excited to try out Redis or DynamoDB or other key value solutions, let me know in the comment section below. Thanks for watching this video and see you in future videos.